This is lesson 2-1's homework assignment in the textbook. We are on page 69 and we are doing numbers 1, 5 to 10, 12 to 14, and 17. So number 1, we are looking at the distributive property. So letter A. Examining the distributive property with just variables, no numbers. So the distributive property says we don't have to add the parentheses first. We can multiply both of the terms that are inside your parentheses by the term on the outside, combining them into two separate new terms. So n times k will go here, and n times w will go here. The plus or the minus is determined by positive or negative. In this case, everything's positive, so it's all going to be plus. There's no negative, so we won't have any minus. Now, if this was actual numbers, we would multiply. If it was 5 and a 2, we'd do 5 times 2 and get 10. But since they're variables, we can't multiply them and get a new variable, but they do combine. So n times k is just n k, and then n times w is just nw. They sit next to each other. They combine into one term. So I have two terms here. And whether this is positive or negative will determine if this is a plus or a minus. Now this is positive, so this is going to be plus, and that's my final answer. But what I don't want you to do is always just take what you see here and put it here, because if I have a negative out here or negatives here, that can change whether this is a plus or a minus. So this plus or minus is determined by a positive or negative of this term. Letter B. G times D minus E. So on these, anytime we see a subtraction like this, I want you to consider this a negative for this term. So when I multiply it, you need to think of it like it's a negative E, and eventually it'll be a number. So first thing we're going to do is distribute here. G times D is GD. Now don't automatically bring this minus down. If I had a negative G out here, this would be a negative times a negative. It'd be positive, and I'd write plus. So you can't just drop this down every single time. In this case, it's going to look like that, though, because this is a positive G times a negative E. So any positive times a negative is a negative, and we express that as subtraction. G times E is just GE. Okay, then letter C, we looked at this property where we can separate these fractions. You've got two terms being added or subtracted on the top. We can split this into two new fractions that have the same denominator, so this becomes n over r plus p over r. Now with variables, it just looks like, okay, cool, we split it up, but why would we do that? But when there's numbers here, sometimes when you split this into two separate fractions, they simplify individually, and it just makes everything a lot cleaner. All right, we're going straight to number 5. Let's put some numbers in here. So m plus 4, and 5's on the right side all of a sudden. So don't let that mess you up. 5 is still going to get distributed to everything. If you want to rewrite it as 5 times m plus 4 like this, you absolutely can. It's the same thing. It doesn't matter which side they put this on. Don't let them confuse you and think that it's different. It's not. So 5 times m, just like you would do 5 times m here, is 5m. 5 times 4 is positive 20, so it's plus 20. Number 6. Okay, we've got x's and n's. When you multiply an x times an x, or any variable times itself, you add the exponent. So this is x to the first times x to the first. X times x is x to the second. So when I go ahead and multiply this times this, first of all, there's really a 1 in front of this. So in terms of multiplying the number, anything times 1 is itself. So my first term is going to have a negative 30 coefficient. That's called a coefficient. And the variable is x times x. That's going to be x squared. Again, don't bring down that plus automatically here. This is a negative 30 times a positive 2. Well, a negative times a positive is a negative, and we express that as subtraction, minus. Now, negative 30 times 2 is negative 60, and the variable has to tag along. Now, the 2 didn't have a variable, but the 30 did. The x goes with it, so it's negative 60x. Negative times a positive is a negative, so this is minus. Negative 30 times 4, that's negative 120. And now what about these variables? They're not the same, so it's just like up here. N times k was nk. X times x was x squared. So if it's a different variable, they just combine. If it's the same variable, then you have to add up the exponent. So x times n is just x n. And it looks just like that. Okay, number 7, a little fraction. So first of all, the 12 comes to the k, that's just 12k. A positive 12 times a negative 1/6 is a negative. And now let's deal with this. So first let's write it out like this. It's 12 over 1 times 1 over 6. Any whole number is really over 1. And when you multiply fractions, you go straight across. So you're going to get 12 on top, you're going to get 6 on the bottom. 12 divided by 6 is 2. So the answer here is 2. So anytime you multiply a whole number times a fraction with a 1 on top, I'll say that again so you can hear. This is like a little shortcut trick so you don't have to do all this every single time. Of course, you could do it in your calculator, but this is one I would never do in my calculator. I just know that since there's a 1 on top, basically the 12 just sits in right there like here, and you're just dividing by the bottom. And I know 12 divides by 6 very nicely. It's 2, and I don't have to go through this extra work. So as soon as I see 12 times 1 over 2, or 1 over 3, or 1 over 4, or 1 over 6, I know that I can just divide by that bottom number. So 12 divided by 6 is 2, and this is done. So that will speed you up in the future if you can remember that little trick. Number 8, they've gone ahead and they've thrown it on the other side again. Don't let that confuse you. So we're distributing to both of them. Multiply the coefficients, that's the numbers, so 10 times 2 is 20. Now it's the same variable, so they combine. B times b is b squared. And when it comes here, the coefficient's 1, so 10 times 1 is positive 10, so plus 10. And a b and a c cannot combine, they stay separate, it's just bc. And number 9. Just distributing a 6, so pretty straightforward. We don't have anything to do with the variables. They're just going to all tag along, and you're just multiplying the front numbers, the coefficients. So 6 times 3 is 18. The v tags along. 6 times negative 8 is negative, so I write minus 48. The w tags along. And 6 times 9 is 54. And the z tags along. Okay, on this one, we just have variables in here. So an a times an a is an a squared, an a times a b is an ab, and the negative 7 is just going to tag along. We do need to take notice that there's a negative here. It'll be a negative times a negative, so this will become a plus. Notice I did all of that before I started, so don't just necessarily jump in and just start going. Analyze the problem, take a second, and just think ahead to what's going to happen, and that will save you a lot of easy mistakes. So a negative times a positive 1 is just going to still be a negative 7, and the a times the a is a squared. Now a negative 7 times a negative 1 is a positive, so I'm going to write plus 7. Okay, the coefficient, remember here, is a 1. So it's negative 7 times negative 1, that's positive 7. And the a and a b just combine, and it's ab. All right, down to number 12. We're going to rewrite this as the sum of two fractions and then check your answer. So we'll talk about what that means in a second. First, let's separate it. So 24 plus 6x over 8. So we can separate this into two fractions. 24 over 8 plus 6x over 8. They both just end up over the 8. Now here's one of these problems where this actually helps us because 24 over 8, I'll do it right underneath so you can see it. 24 over 8 is just 3. 24 divided by 8 is just 3. And 6 over 8, you can simplify that fraction. You can divide these both by 2. And so 6/8 is the same as 3/4 x. If you like the x on top like it was here, that's fine, or I can sit next to it. This is also equal to, if you like the decimal version, 6 divided by 8 or 3 divided by 4. Same thing. You get a nice decimal of 0.75. So if you wanted to write it as a decimal, you could do 3 plus 0.75x. So all three of these are equivalent, but we're going to check our answer and prove it. So what you're going to do is you're going to plug in any number you want to both locations and make sure you get the same answer. If I plug in a 10 here and I plug in a 10 here, I have to get the same answer. Otherwise, these are not all equal, and I haven't simplified correctly. A simplified expression is still going to give you the same answer when you plug in the number. It's just simpler and easier to deal with, which is why we simplify. So let's go ahead and check it. I'll go ahead and use 10 just because it's easy. So I'm going to plug in 10 here. 24 plus 6 times 10 over 8. That's 60. So 60 plus 24 is 84 divided by 8. It's not going to give me a perfect decimal, but that's okay. 10.5. So if I plug 10 into either one of these, I have to get 10.5. If I don't, then I did something wrong. These have to give me the same answer. So I'll go ahead and use the decimal one. 3 plus 0.75 times 10. Now, 10 was really nice to use for a decimal because anytime you multiply by 10, it just shifts that decimal over one spot. I'll show you what I mean. 0.75 times 10, it's going to move that decimal one spot. It's going to be 7.5. So it's 3 plus 7.5, which is 10.5. It checks out, which means I've done a good job of simplifying. I get the same answer when I plug in the same number. So that's how you check your answer. Okay, jump into number 13. Kind of go in reverse here, and you'll see in 2-2's work, we're going to do a lot more with this. It's called factoring. So we're starting off with 24 times k plus m. And on this one, we're not actually factoring. We're still going the same direction. So it's going to equal. And so they basically just want you to fill it in. So forget this. This is just probably making your life more complicated by looking at that. Just distribute it. 24 times k would be 24k. That's what they're looking for here. The blank is k. 24 times m would be 24m. So m goes in right here. So they're just showing it to you like in a different style. Don't let it confuse you. So the blanks here is the k and the m. So when you look at your answer key and it says just k and m, they just wanted you to fill in the blanks. That's all. Okay, don't let it confuse you. All right, 14. So we're kind of given the answer in a way, and we have to go back to this. So they're bringing it back into parentheses. So 10 times something in here. So think about it. If you started with this, 10 times something gave you 10a, and 10 times something gave you 80. We're working backwards. Okay, and we're going to do, again, a lot more of this in the very next section, factoring. So this is called factoring out of 10. You're going to see that. So 10 times what gave me 10a? So don't put another 10 here, because 10 times 10 will be 100. I didn't get 100, I got 10. So it's a 1, and it has to have an a on it. So if you want to write 1a, you can, but it's really just a. 10 times a is 10a. Now 10 times something gave me 80. That would just be 8. So you just double check yourself. Run these through. 10 times a is 10a. 10 times this is 80. Well, that's what I started with. This is good. But again, the answer key is going to give you just the blanks. So the blanks was a and 8. And that's what the answer key gave you. Okay, number 17 now. Quick review from last section. We're doing some mean absolute deviation. So we know these take a little bit of work. So letter A, we're going to find the mean of this, and then letter B, we're going to find the mean absolute deviation. So we have to find the mean first anyway. So this is 17. So we have 1, 2, does it tell you? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So we have 10 of these. So we're going to add them all up, and we're going to divide by 10. So you don't have to write it out like this, but I'm going to continue to do so you can see it and have some consistency. But you could just plug all this into the calculator and divide by 10. Okay, you add them all up and divide by 10. 403 divided by 10 is 40.3. So the mean or the average is 40.3. So the average number of films was 40.3. That was part A. Part B, find the mean absolute deviation. So again, mean absolute deviation tells you how consistent the numbers are. So the average is 40.3, but you can get that average with numbers really high and really low, and they meet in the middle for the average, or all of the numbers can be really close to this, and they still average out to that. So the mean absolute deviation will give you an idea of how spread out your numbers are, or how clustered they are, how consistent the data is, or inconsistent the data is. So what we have to do is we have to subtract every single one of these by 40.3. What that's doing is telling you how far from the average each piece of data is. We'll get 10 new pieces of data. Each one individually shows us how far that data is from the average. And then we're going to take all of that data and average that just to get one number that represents all of that. So I'm going to write it out. Again, you don't have to do it this way. 40.3 minus each one. And I'm actually going to number this 1 through 10, so I know that I've gotten all of them. Because sometimes the most common mistake is you just miss a number, and then you're like, what did I do wrong? You just missed one. So this seems tedious, like I'm writing all of this. You don't have to. You could just punch this in the calculator. 40.3 minus this, put the answer down. 40.3 minus this, put the answer down. But again, I'm going to show you what I'm doing so you can fully understand it. But if this becomes too much work and you know what you're doing, you can kind of condense it a little bit. All right, so it's going to be a 34, 52, 32, 52, 27, 46, 52, 32, 46, 30. Okay, I got them all. I'm going to go ahead and run the numbers, do the subtraction. I get 10 new pieces of data, and then I'm just going to average all that new data out into one nice new average. So dividing by 10, that's the other trick. Sometimes people forget what to divide by. They want to divide by the mean or something like that. You're doing the exact same process that you did up here after you've got this data. Divide by how many you have. All right, so let's run all these numbers. And if you get a negative, you're going to make it positive. Because we are just trying to find out the distance these numbers are from the average. We're not expressing whether it was high or low. That's what the positive and negative would do for you, but we just want to know how far away is it. So distance is always expressed as a positive number. So technically these are absolute value. So technically you could do this, put the absolute value around the outside. That's technically what you're doing. That's why it's called mean absolute deviation. It's the absolute value. Okay, so I've got 10 new pieces of data. Hopefully I did those all correctly. And we are going to combine those. So it's going to look just like this. So I'll go ahead and do that just so you can see it. 6.3, all of them added up. Some of you like to just add straight down. That's fine. You definitely don't have to write out as much as I'm writing. Okay, and then all of that gets divided by, we're going to average that out. There's 10 pieces of data, so we're dividing by 10. So I get 93, so it's going to be 93 on top, divided by 10. It's 9.3. So this is part B. This is my mean absolute deviation. So what this means is, on average, each piece of data is within 9.3 of the overall average.